What's going on, everyone? In this video, we're going to be taking a look at scientific notation very, very quickly because as in the AISL curriculum, we kind of glance over it a bit. But it's important for you to know what it is and why it comes about. So let's go ahead and let's take a look. So scientific notation deals with this powers of 10, using 10 as a base. So when we are talking about 10 cubed, we're talking about 1,000 or 1,000 over 1. Now, if we're talking about 10 squared, if you put it on your calculator, it's just 100, which is just 100 over 1. 10 to the 1 is just itself. 10 to the 0 is 1. But now, what happens if I go into the negatives? So what that really is doing is it is moving the decimal place over. Because if you think about it, 10 to the 3, I have a decimal place right here. Then here it's over in 100. It's like I moved it over by one spot. Then here I have it from 2 to 1. I go from 100 to 10. That means I just moved it over 1 to be 10. Then from 1 to 0, I moved it over to be 1. So if I had 10 to the negative 1, I would move the decimal place right here to over here to be 0.1, which would be 1/10. And if I kept that pattern going, I would then have 1 over 100. If I kept that pattern going, I would have 2 zeros, and then I would have 1 all over 1,000. And that's what that would look like in terms of representing it as a power of 10, as a decimal, and as a fraction. And it's important to note that a lot of calculators will spit out these numbers that might look a little bit weird. But what this is, when you say 5e negative 3, what it's saying is that the exponent that's attached to 10 is going to be negative 3. So that e stands for exponent, and that's going to be assuming the base of 10. So another way of thinking about that, and this will be directly related to our scientific notation, and it's 5 times that 10 base with a negative 3. So what that means is you're going to have 0.005. Why that? Because, well, I have negative 3 as my exponent, and just like in here where I'm moving this over as I get smaller and smaller and smaller, same thing here. I have 5.0, so let's say I had 5.0 like that. This would move over 1, 2, 3 places. There you go. 1.2 e to the 4 would be 1.2 times 10 to the 4. So now we have a positive exponent, so what that means is we're going to actually move this over to the right by 4 places. So if I had 1.2, and let me just add some zeros for clarity's sake, this would move over 1, 2, 3, 4. So it'd be right there, meaning I have 1, 2, 3 zeros to the right of that, 2. So 1, 2, 3.0, that's going to give me 12,000. Okay, another way of writing that would be 1.2 times 10 to the 4th. So I hope that helped. Let's go ahead and look at a table to see what these look like expanded and as well as contracted. So here we have an empty table. Let's say we have 10 squared times 10 cubed. So what that would mean is, well, we'd have our 10 squared here, 10 times 10, and then times 10 to the 3, 10 to the 3, and then how many 10s do we have? We have 1, 2, 3, 4, 5 of them being multiplied together. That's going to give us 10 to the power of 5. So let's take a look at how we can kind of go in different directions with this. So let's say we have 1, 2, 3, 4, 5, 6, 7, 8, 9 10s all being multiplied by each other. That means that we're going to have 10 to the power of 9. And then another way of breaking this down by using the parentheses as clues, we have 1, 2, 3, 4, 1, 2, 3, 4, 5 in each of these parentheses sets. So I'd have 10 to the 4 times 10 to the 5. What about 10 to the 8? So 10 to the 8 would just be 10 times 10 times 10 times 10. That's 1, 2, 3, 4 10s times 1, 5, 6, 7, and 8. 10 to the power of 8 like that. I'm not going to worry so much about the expression. Here we have 10 to the 5 times 10 to the 6. So that would look like 10 times 10 times 10 times 10 times 10. That's 5 10s times 10, 3, 2, 3, 4, 5, and 6. Ran out of room there. And how many 10s would we have in total? Well, we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's going to be here. So now let's say I have 10 squared to the power of 3. So that means is I'm going to have 10 squared 3 times. So I'm going to have 10 squared, 10 squared, 10 squared. Then how many 10s does that give me? Well, it's going to give me 1, 2, 3, 4, 5, and 6. So that's going to give me 10 to the power of 6. Okay? So let's take a look at how these laws and rules are written a little bit more explicitly. So when we say x to the power of 1 equals x, it just means that it is itself. So whenever, let's say I had a number 5 to the power of 1. Well, it's just going to be 5. If I have anything to the power of 0, that's going to be equal to 1. If I have anything to the negative power, all that means is that I put it in the denominator, or I'm sorry, if it's in the denominator, you also put it in the numerator. You basically just reciprocate it to a positive exponent. So now let's say I have 5 to the power of 2 times 5 to the power of 3. So just like in our last example, but now we're writing it in a little bit more mathematical way, I would have 2 5s being multiplied by each other times 3 5s being multiplied by each other. And remember that with these x's right here, that's translated to this right here. It has to be the same base. So that would give me 5 to the power of 5. So now let's say I had 5 to the power of 5 all over 5 to the power of 3. What that's going to be is 5 to the power of that first exponent minus that second exponent, 5 squared. So let's say I have 5 cubed squared. That's going to be equal to 5 times these exponents multiplied by each other, 5 to the power of 6. That is going to be the same thing as this last example right here, if you want to go back and take a look. So now let's say I have xy to the power of n. So let's say I have 5 times 3 to the power of 4. This can distribute across these different numbers. So this would be like 5 to the power of 4 times 3 to the power of 4. And that's going to be quite a large number. And if I wanted to calculate that out, I'd have to go into a calculator and say 5 to the power of 4 times 3 to the power of 4. 50,625. So quite large, but that's how you go through that. Now let's say I'm going to have 5 all over 2 to the power of 4. What would that look like? Well, again, this would just distribute to each term like so. And if I wanted to calculate what that would be, I can go in my handy-dandy calculator, do 5 to the power of 4, then divide that by 2 to the power of 4, and I would get 39.0625. So that would give me 39.0625. Again, it's more about the method that's the most important, is recognizing that this exponent does distribute to both of those terms. And then if I had x to the power of negative n, again, this is just a reiteration of what is going on up here. So if I had, let's say, 2 to the power of negative 9, that would give me 1 all over 2 to the power of positive 9. And if I had 1 all over 2 to the power of negative 9, that would be equal to 2 to the power of positive 9. As long as you reciprocate it, you can use the opposite sign for that. So again, I hope that sheds a little bit of light on the laws of exponents. And then in our next video, we'll go ahead and take a look at some examples of using numbers rather than just symbols. So hopefully that helped, and I'll see you all in the next video.